So today we're talking about section 3.5, derivatives of trig functions. Super fun functions, guys. All right, so the first few are just the derivatives, and you have to memorize these. There will be a surprise quick quiz over all of these. It's not a surprise because I just told you about it. Okay, but derivative of sine, if you remember it from last year, it's cosine. The derivative of cosine, however, is negative sine of x. The derivative of tangent is secant squared x. The derivative of cotangent, I want you to kind of notice that these are co-buddies. We had cosine, sine. This one was secant. That means this one is going to be cosecant squared, but negative. Cosecant squared. So we have co-buddies. Tangent and cotangent are co-buddies. Secant and cosecant are co-buddies. Secant, the derivative is secant x, tangent x. So the co-buddy for cosecant, you're just going to co each of these. So it's negative cosecant of x, cotangent of x. So that's the way I always remember them, is that they're the co-buddies. That way you only have to really memorize 3 of them. I also want to point out that all of the derivatives of the c functions are negative. So that's something to remember as well. So now using that, I want you in part A to use the product rule to find the derivative. All right, so I did first times derivative of second plus second times derivative of first, and then just kind of rewrote it. I always like to put that 2x up here. You cannot combine these two. If you need to remind yourself, that one's protected. It's in a bubble. You cannot add anything into that. So we've got x squared cosine x plus 2x sine x, and then if you wanted to, you could factor an x out of both of them. You do not have to do this. This is sufficient. All right, for part B, I want you to use the quotient rule to find the derivative of this one. All right, so on this one, I did low d high less high d low over the denominator squared we go. So then I just went ahead and distributed. So I get negative sine plus sine squared. And then over here I got plus cosine squared all over denominator squared. Now here's where some cool, amazing, delicious math shows up. This right here, sine squared plus cosine squared of x, that's the Pythagorean identity. It's on my back wall, but it is one of those that they kind of expect that you remember from last year. But the Pythagorean identity, if you ever have a sine squared plus cosine squared, that's equal to 1. So I want you to notice up on top, I'm left with 1 minus sine of x. And on the bottom, I have 1 minus sine of x squared. So I can cancel one of these out. So I'm left with 1 over 1 minus sine of x. In a multiple choice question, you would be expected to go all the way down to this. That would show up as the derivative. Otherwise, on a free response or question on my type of a test, if you got to here, good to go. So next is this derivative of a jerk. It's not the definition of Mrs. Meyer, I swear. So it says the jerk is the derivative of acceleration, or the third derivative of displacement. So if a body's position at time t is s of t, the jerk then would be considered s triple prime of t. And just to kind of go through the motion here, it's also second derivative of velocity, or the first derivative of acceleration. That's the jerk. People who have motion sickness, I like to think about if you can't read in a car, or if you think about when someone accelerates too quickly or decelerates really quickly, what happens to your body? Well, it jerks. So that is what is described here. Fun fact for the day, beyond the third derivative, the fourth, fifth, and sixth derivatives are snap, crackle, and pop. Not even kidding. Isn't that hilarious? I think it's hilarious. All right, so example 2. It says we've got this displacement function of sine of t, so they want velocity, acceleration, and jerk. So velocity would just be our first derivative. So the derivative of sine was cosine. Our acceleration is the derivative again. So derivative of cosine is negative sine. And so our jerk would be derivative one more time. So the derivative of negative sine is going to be negative cosine. All right, on example 3, now it says we're going to find the equations of the lines that are tangent and normal to the graph. As soon as I see this phrase, equation for the lines, I remind myself that the only things I need are a point and a slope. And they're giving me at x equals 2. So my ordered pair is 2 tangent of 2 over 2. And you can just leave it like that. You don't have to put it in your calculator. If you want to do the decimals, then go for it. But go ahead and figure out what is the slope. You need to use quotient rule to find the slope. All right, so again, I did low d high less high d low over the denominator squared we go. And then I plugged in 2. Just as a note, secant squared is the same thing as 1 over cosine of 2 squared. So that's how I entered that into my calculator. In fact, you can kind of see it here. I did 2 times 1 over cosine of 2 squared minus tangent of 2, and then divided by 4. So my slope is 3.433. So now I want to write my equation of my tangent line. And I did figure out tangent of 2 over 2 is negative 1.093. Remember, round to 3 decimal places always. So my tangent line is y plus 1.093, 3.433, x minus 2. So then for my normal line, the only thing I have to do is change the slope to be the opposite reciprocal. So y plus 1.093 equals 1 over 3.433, negative 1, x minus 2. Ta-da! All right, for secant of x, they want the second derivative. Please find the first derivative first. And that one is one that we should memorize from the first page, secant x tangent x. But now to do the second derivative, I have to use product rule. I've got 2 functions being multiplied. So go ahead and do product rule and come up with the second derivative of secant. So we did first times derivative of second plus second times derivative of first. And then I kind of combined my like terms. So I've got secant cubed and then secant tangent squared. And you can pull out the secant again, but you do not have to. Last but not least, it says find the derivative of the function tangent of x times 2 plus cosine of x. So this again is a product rule. So would you please find that derivative? So again, I did first times derivative of second plus second times derivative of first. So I get negative tangent x sine x here. And then when I distributed, I got 2 secant squared, and then I got cosine times secant squared. Again, secant squared is 1 over cosine squared. So notice I wrote it as cosine over cosine squared. That one cancels out with one of those on the bottom, leaving me with just 1 secant, or 1 over cosine. So that is my simplification. Yay. So this one, all the rules still apply. It's just we're adding in those new trig derivatives. Make sure you memorize those. Have a lovely day.